So today you only have two different problems that we're going to be working on. We're going to be working on number 16 and number 17. I will be using the Staplet so that way you guys can see how that works. If you want to see how it works on the calculator, the TI-84, you'll pop back to yesterday's lesson and watch the homework problem from that. I'm going to kind of alternate between the two so that you guys can get accustomed to both. Number 16, they're actually just asking for a multiple choice question, and there's not much to describe there, but it says, in addition to the regression line, the report on Mumbai measurements say that R squared is 0.95. Remember, our R squared value being 0.95 means that 95% of the variation in whatever your Y values are here in height is accounted for by the least squares regression line. The answer is D. That is the only one that mentions 95% of the variation. Remember, this is only talking about variation. In number 17, you actually have a problem, a review problem that we'll go ahead and look at. So in this one, the heavier you are, do you burn more energy? So we're going to find that out by putting data into our Staplet. So I'm actually going to pull out the Staplet so that it can be a little bit more easily accessible. Move stuff around for just a second. And there we go. I want a lot of stuff going here. So, okay, I'm going to go ahead and go back one so that you guys can, to remind you that we're going to be going to the two quantitative variables. This time we have two different variables that we're measuring. The explanatory here is definitely the mass, okay, the mass or the weight, because we're trying to figure out, does weight cause the response of metabolic rate? Okay, so I'm going to go ahead and put in the values here. We have the weights of 36.1, then 54.6, 48.5, 50.6, 42, 42.3. Where am I? That was, let me see here, 42. I'm sorry, it's 40.3. 40.3, I'm glad I caught that now. 40.3, 33.1, 42.4, 34.5, 51.1. To move this over a little. 51.1. Then I have 41.2. In my next set, I have 995. So these are metabolic rates: 1425, 1396, 1418, 1502, 1256, 1189, 913, 1124, 1052, 1347. So you'll be going through this exact same process in yours. I'm going to hit begin analysis. Oh no, it looks like something went wrong. So this is a good lesson to make sure that I obviously put in something incorrectly here. There it is. I'm missing 48.5. I'm missing 42. Then I had the 50.6, then 42, then 40.3, then 33.1, then 42.4, 35. Okay, that should be right now. So I'm going to hit begin analysis. So I had forgotten one of the points, and it's pretty easy to go back and figure out from your data which one was missing. Here is my graph, and I am definitely noticing a positive trend. I always try to, before I go in and actually create the least squares regression line, or in this one, calculate the correlation coefficient, I usually try to look here to see what I have going on. So there's obviously a positive, and I would say moderately strong, positive linear correlation between these. It looks like as I increase body weight or mass, then the metabolic rate also increases. The metabolic rate will also increase. So that's kind of what I have going on here. Positive slope, I'm expecting that. I'm expecting a pretty high correlation. I might say like 0.7 or 0.8 even. I'm gonna do that now. When I calculate that, it's actually closer to 0.9. It's 0.87. So that's a pretty strong correlation, which is great. And now we can calculate the least squares regression line. I'm going to ignore this, but these are residuals. This is showing you like the points being above and below the line. This one right here has the smallest residual. That's for sure the smallest residual. This one probably has the largest. You'll notice this is only 12 pounds off, or 13 pounds. Or 13, I'm sorry, this is metabolic rate. So it's only 13 off. This one is 207 off. So that kind of shows you what a least squares regression residual plot looks like. So looking at this, the least squares regression line is here. We have y hat, so that's going to be my mass, is equal to 201.16 plus 24.02 times my x, which would be my actual mass. I think I said it wrong. The rate is equal to the mass. So x is my mass. Okay, so you'll notice that I have that here. That's the value that I have in here. In C, it says, what can you say about the slope or interpret the slope? So in that one, as you increase your x by 1, so in this one, as I add 1 kilogram of mass, my y, or in this case, my metabolic rate increases because it's a positive slope by 24, about 24. Okay, in D, they ask you to calculate a residual. So let me look at that. It says calculate and interpret the residual for a woman who had a lean mass, body mass of 50.6. Well, we have the value that actually happened. The metabolic rate is actually 1502, but now we need to find what my predicted is in order to calculate a residual. So I plugged in that 50.6 and I got that my residual should have been about 1417. That's our prediction. Our prediction is that she would have a metabolic rate of 1417. So what I did then is I took my y, my actual value minus my predicted, that's what a residual is, my actual minus my predicted, and we were off by 85. She had a value that was 85, her metabolic rate was 85 more than we predicted for her.